Hi, my name is Brendon Albertson, and in this presentation I'll be discussing the development and the rationale behind TextMix, which is a call application for creating sentence scrambles using natural language processing techniques. In this video I'll go over why this app was made, how it works, and some of the initial piloting and some of the troubleshooting and limitations and future steps that came up in this app's development. This is still very much a work in progress, and it is a proof of concept application. Specifically, the application was designed to answer some of the following design questions. We wanted to see whether a tool could be used in call to create sentence scrambles, not by scrambling words, but by scrambling syntactic units or meaningful chunks, which I'll get into later, using natural language processing techniques. We wanted the app to be compatible with large sources of text, so APIs like Wikipedia or news headlines or user pasted text or other open educational resources. And we wanted it to be very easy to use, intuitive, and allow teachers to quickly create and share these activities with students without any downloads and by simply sharing a quick URL. So the best way to know how this app works first is just to go through a little tutorial here. So there is a student mode and teacher mode. The teacher mode has more settings, such as the ability to combine chunks, which I'll get into later. It's got different game modes. The reading mode keeps the sentences on the screen, and also an optional timer. There are different text sources with APIs like Wikipedia, and in this example there's also pasting text, and I'll show an example here of a preset text. But first, Wikipedia, simple English. If I type in a search term like tea and I press start, we create a sentence scramble that has been chunked into pieces after it has been parsed using natural language processing. And we have to unscramble the sentence here. This is the first sentence of the Simple English Wikipedia article on tea. And the sentence stays at the top of the screen, and we proceed to the next sentence. So we're essentially reading this article sentence by sentence and unscrambling these sentences here. So a bit of the background and the theory behind TextMix. First, there are a couple of different concepts here that kind of came together to create this app. The first is natural language processing. This is a technology that is used in many different applications, from spam filtering in your email to predictive search to analyzing customer reviews and machine translation. It has applications in education. Mostly these have been limited to things like automated scoring, providing feedback, autocorrect, simplifying texts for lower level learners, computerized tutoring systems. So these are powerful applications in education. However, at the sentence level and for language teaching in particular, NLP hasn't necessarily been used it can parse sentences, but this technology to parse sentences hasn't necessarily been used to help learners understand syntax or sentence structure. So using NLP, we can generate these very nice diagrams down here. This is created with Python's Spacey library, and we can parse the verb, the adjective. We can see the relationships between syntactic units of a sentence, such as the subject and the object, what a preposition connects with. And so this is a lot of very interesting and potentially useful information that could be applied to language teaching, although that's rarely the case in most NLP applications in education. So this app, TextMix, was sort of a proof of concept that natural language processing and in particular sentence parsing techniques can be used to help learners process sentence structure and syntax, which we'll get into in a bit. The second concept here was chunking, and chunking is when a sentence is separated into pieces, and native speakers do this naturally when they read, and advanced second language learners also do this, and it improves processing efficiency in reading and also in listening. And this is something that can be automated using natural language processing and sentence parsing techniques. I mentioned Spacey before. For the purposes of TextMix, the Python Natural Language Toolkit was used. Chunks may also be acquired in the lexicon as a single unit if they're made noticeable, and this includes things like collocations, such as around the world, or formulaic expressions, they're sometimes called. Another concept here was input enhancement, which just means drawing attention to particular features of a text in order to raise awareness. This could be grammatical structures, it could be collocations or vocabulary, transition words, highlighting, underlining, using italics, or even using spaces, as in this example, is a way to enhance text, textual input enhancement. So in the case of collocations, we might separate text this way, all over the world, to show learners that that is a unit that can be kind of learned on its own. It's a common formulaic expression. We might chunk text into noun phrases. There are different ways that we could chunk texts, and there are different ways that we could enhance text depending on what we want learners to focus on. The last concept here was a learning activity known as a sentence scramble. Sentence scrambles have been used to measure syntactic awareness. They have been shown to help acquire present simple tense, and they're a fun activity that represents something called a desirable difficulty, which just means learners have to process the sentences a little bit more, which can help their learning. And so here's an example of a sentence scramble, just like we saw with TextMix. With sentence scrambles, it's important to note we can scramble the sentence by word, we can scramble it by clause, or we could scramble it by n-gram, so we could scramble every 2 words, every 3 words. But for the purposes of this project, one of the design questions was we wanted to see whether we could scramble a sentence by meaningful chunk. And so for that purpose, we need to parse the sentence. And so that's where natural language processing came into play. Existing call apps for making sentence scrambles. There are two that I was aware of. I could not find any other than these two. One of them is from the hot potato suite called JMix, and the other one is the Flexible Language Acquisition Project from the University of Waikato. And these are both excellent apps. They do have limitations though. So JMix scrambles by every word or every few words, depending on what the user specifies. It does require a download. It requires the user to specify where the sentences are divided before they get scrambled. In the Flax project, this is an excellent tool for raising learners' awareness of grammatical features, such as adverbs or prepositions, because it only scrambles 3 words per sentence, and it will only scramble the target language. So these are both excellent tools, although they do have limitations. So back to the design questions that drove TextMix. So again, just to review, we wanted to see if natural language processing could scramble sentences by chunk instead of word, and if it could be connected with large sources of text that could be easily imported and used, as in the example of Wikipedia, and easily shareable and savable by teachers. There are different chunking methods we could use when we chop up or divide a sentence before we scramble it. The first one is just, we could scramble it by every 2 words or every 3 words and so on. We could use natural language processing to parse the sentence and divide it into things like noun phrases, prepositional phrases, and then we could combine these into pairs. These highlighted parts here represent the meaningful chunks. So these are pedagogically useful, we can say. In this example, researchers is the subject of the sentence. Tried to find is a compound verb. A sense is a noun phrase. Of body awareness is a prepositional phrase. So these are all kind of useful grammatical chunks that we can have our learners work with. We do have some useful chunks when we chunk by every second word. To find is an infinitive. Canines have and researchers tried. Those are subject-verb combinations. However, it's important to note that when we chunk by every 2 words, we're essentially relying on chance, because we also come up with these sort of meaningless chunks like out, whether, and so on. One drawback of this approach using NLP is that we miss out on, for example here, we miss out on find out, which is a phrasal verb. Very useful to point out phrasal verbs to learners, but the algorithm here essentially prioritized tried to find, which is a compound verb. And because it prioritized the compound verb tried to find, it did not catch the phrasal verb find out. So we can chunk one thing or another in many cases, but we can't always chunk both. Behind the scenes, we use the Python Natural Language Toolkit, which uses regular expressions to define each chunk. And so we have here prepositional phrase or a noun phrase, for example, was defined as 0 or more prepositions, 0 or more determiners, 0 or more adjectives, and 1 or more nouns. And these definitions can get quite complex, and they can be tweaked to be more or less accurate, but they are all rely on regular expression matching to define the chunks. The flow of the app essentially works this way. Text is imported, it is tokenized into sentences, and then words, and then tagged with parts of speech, and then the algorithm and the regular expression matches these tokens to chunk them, and then the chunks are scrambled and possibly combined depending on the settings that are specified by the user. There was a short pilot of this app, and the research questions for this were we wanted to see whether participants would increase their ability to correctly solve these sentence scrambles over a 2-week time, which might show that they're raising their syntactic awareness and they're getting more familiar with the way that sentences are structured. Number 2, we wanted to see how they felt about the app, if they enjoyed it. And number 3, this is to be assessed later in a pre and post test. Will learners retain any of these collocations that they encounter while playing the app? Again, a very short pilot. 2 participants selected 10 texts from all of the available CEFR level C1 texts on Breaking News English, and they played these 10 texts over a course of 2 weeks. There were no decrease found in the number of incorrectly solved sentences. So again, we can't say that this app improved their ability to unscramble sentences, but again, it was a very short amount of time. The 2 participants did, however, mention that the app was fun. They thought it was helpful for understanding the sentence structure. So there's some potential here. Limitations. As I mentioned before, chunking sentences with regular expressions in NLP is helpful for capturing useful collocations in some cases, such as promising news. But in other cases, it does not capture collocations, such as suffer from. And that's because it prioritized, in this case, the prepositional phrase from baldness. So we have to choose what we want to prioritize when we chunk. We can prioritize prepositional phrases or phrasal verbs, or perhaps verb preposition pairs or adjective preposition pairs, such as afraid of, excited about. But we can't always chunk every pedagogically useful chunk that we want. A partial solution to this would be to create options in the app where the user can select the algorithm for chunking. And so perhaps the teacher could select phrasal verbs, and the algorithm would prioritize chunking phrasal verbs depending on what the teacher would like to focus on and have students notice. Another solution would be to match, if we want to focus learners' attention on collocations and prioritize collocations, we could have the app match to lists of known collocations. And there are several of these lists here. The academic collocations list has a very large number, whereas the 50 most frequent collocations has only a smaller number of very common ones. So this way we could guarantee that collocations are chunked, but we wouldn't necessarily be chunking syntactic parts of the sentence, like noun phrases, prepositional phrases, and so on. So essentially this diagram here shows what our issue is. We are sort of catching butterflies in a net, and we can catch certain butterflies, but not others. We can't always catch all the butterflies we want to. We can't always chunk all of the collocations or the useful parts of a sentence. We need to choose what we want to prioritize. So future steps. Hopefully this app provides a proof of concept that natural language processing sentence parsing techniques can be applied to computer-assisted language learning applications. More piloting is definitely needed. There are different ways of chunking sentences that we could explore. We could also do pre and post tests to measure learners' syntactic awareness and how well they might retain the collocations that they encounter. And we could also connect with additional sources of text. Right now, the app connects with Wikipedia, the News API for news headlines, pasted text, and a variety of pre-uploaded texts in a database that all came from Open Educational Resources, or OERs. I'd welcome any feedback, any collaboration, or suggestions that you have. You're welcome to try the app. This is the website here. Feel free to contact me or visit my blog where I post updates on TextMix. Thank you very much.